My name is Sanmal Bumkar. I'm a leader for product management for the Meraki Wireless product portfolio. And with me today, we have Jim. Jim, do you want to go ahead and introduce?
Yep, I am Jim Florwick. I'm a technical lead with the technical marketing for EN Access. I'm a wireless guy.
As you can imagine, both of us from wireless. So today we want to talk about some of the innovations that are coming on the wireless portfolio at Cisco. And there's three key topics we want to cover. What are we doing towards, enabling some of our sustainability efforts for our customers? And then Jim is going to talk about some of the RF excellence that he's been working about. And then the last topic is AIOps. I think one of the things that everybody talks about is intelligence assurance, AIOps. But today we want to talk about something interesting, that is our firmware rollout and how we do AIOps in there and what happens under the hood when you just click upgrade firmware. And so with that, before I get into the details, I quickly wanted to touch upon some of the topics that the previous team covered, and that is around the announcement that happened today at Cisco Live about the unification of Meraki and Catalyst. And I think for our teams, what we are trying to do, again, transform those customer experiences and make it simple for our customers. And to do that, what we're actually doing is, for wireless, we have announced 3 new APs as well going forward. So they are called the CW9166, CW9164, and CW9162. Now, if you recall, the branding is slightly different. It's CW. CW represents Catalyst Wireless, and that's the Converse product portfolio going forward. So that's a clear indicator of what's going to, be available going forward for our Converse portfolio. And again, as the team mentioned, you can go between the DNA mode or the Meraki mode, and you can do that.
I have a lot to go through. We're going to dive deep on Clean Air Pro, but there's a lot of exciting stuff going right now. AP power optimizations for one, sustainability. One of the things that we released in 17.8 code allows you to, and since we've started releasing APs with 6 gigahertz, people have been looking at the power draw on those APs, so we wanted to provide a way to optimize that. Not every situation requires for 4x4, 8x8 radios. What the power optimizations let you do is determine how many spatial streams you want to operate on a radio, whether you want the radio on or not. And it also gives you a calendaring availability in the application. So for instance, you want to have one profile during the day and a different profile in the evening. So that's in the controller today at 17.8. 17.10, we're going to put the ability to be able to reallocate that power on the switch. If you're not using that power for this AP, in real time, can I shift that power over to another profile? The answer is going to be yes. Ultimately, this is going to wind up at DNA Center, and it's going to give you the ability to monitor your power utilization and how much you're consuming at different points in the day. So we think that's going to be big. ZeroWeight DFS does exactly what it says. You probably heard ZeroWeight DFS before in the context of the RF ASIC. We've had ZeroWeight DFS ready to go for a while. It's a very, very regulatory dependent thing. ZeroWeight DFS does exactly what it says. It pre-cacks the channel. It clears that DFS radar channel that we have to sit on right now and listen to for 60 seconds. It does this in the background using extra streams. Not every packet is 4x4 or 8x8. So we're able to use that spatial stream in the background 2 different ways. This is limited right now to only ETSI and only FCC. And there's 2 different methods that we're going to do this. In ETSI, because this is dependent upon regulatory, my rules in ETSI say if I clear a channel for radar, then that channel is clear. As long as that AP has power, I don't reboot it, and I don't see radar. So I'm able in ETSI to go in the background and scan the entire DFS channel list if I wish to and keep that all available. Makes life very simple over there, because no matter what DNA sees, or DCA comes out and says for a channel, I'm going to get that channel, and I don't have to wait. I don't have to scan. I just start operations as soon as I move. In FCC, I'm allowed to do a rolling CAC. The rolling CAC says that I've got to perform a channel check. And if I have a channel that I'm going to select between, for instance, if I have dual 5 gigahertz, I can select a channel that's good for both. Once I have that channel, it's going to become my reserve channel, and that's the channel I'm going to CAC. I have to do that continuously in FCC. So if I want to use a channel, it has to be monitored continuously. But I'm able to do this in FCC and in ETSI. Under the hood, If I take a look at the command line right now in FCC, and this is an example for FCC, it's going to tell me my inclusion list first that I have it turned on, my inclusion list, which has my extra channels, my exclusion list. I'm not doing a pre-CAC, I'm doing a rolling CAC here, and that my CAC status is complete. I have channel 108 for 40 megahertz, which is going to replace either 52, 56, 108, and 112. So this channel combination would be available to either one of those 5 gigahertz. If I didn't have a channel that I could pick that were going to be that 100 megahertz needed between those 5 gigahertz channels, I would simply, I would actually pick the one that is most busy to back up. So I would still do a reserve channel. It's also very possible that my backup channel would be the result of a mini DCA run, and I don't need a CAC at all because it's not a DFS channel. Turning it on, very simple in an RF profile or at the global level. Clean Air Pro. All right, Clean Air Pro. This is something I'm actually really excited about because I got hired into from Cognio into Cisco when we created Clean Air. And Clean Air was built at a time when we really needed that. Every microwave oven, every phone, we were all in 2.4 gigahertz only. It was horrible. And I'll share a story with you because about 6 or 7 years ago, we went looking for, do any of you remember those little cameras? We used to turn on the video camera and send that real nice spike into the spectrum. Somebody called, they were looking for some of those, and I went looking for them, and after days of not being able to find them on the internet, I called Schwann, which was the original manufacturer. They put me through to their product manager, and I kid you not, the guy gets on the phone and he says, oh yeah, we discontinued those. And I said, well, why? And he said, they interfered with Wi-Fi. No. Called the Cognio guy, said, we're not getting any more of those, and oh yeah, we win. So that was then. This is now. Okay, Clean Air has been around now since 2010. It's a 12-year run. We moved it into the RF ASIC. Suddenly we got 60 and 1,200 more megahertz to scale. 1,200 more megahertz we've got to scan. That's a lot of solution. Clean Air Pro is the answer to that. I've got a new scanning engine into 6 gigahertz, 2.4, 5, and 6 gigahertz band support, multi-radio architecture, AI/ML driven scan radio. I'll explain that. Yes, it has to be part of every name. This one actually has ML. ML-based interference classification on the AP. What does all that mean? Well, let's take the journey first. This has been out there since 17.7. And in 17.7, it was responsible for packet captures, providing us insight into WIDs and WIPs and rogue detection. 17.8, we got spectrum-based, which gave me the 6 gigahertz spectrum visibility in DNAC's ICAP spectrum feature. I also got several 6 gigahertz enhancements and fast locate support, which is some of the things that RFA6's been doing. In 17.9, which we're demoing down in the Innovation Center right now, I got my ML-based interference classifiers. And frankly, as a Clean Air guy, this is what Jim has been waiting for. If you're going to replace Clean Air, it's got to be able to do these classifications. And I've seen other solutions that were not Clean Air specific. Frankly, these guys hit it out of the park. I'm sitting in my room. I just did some demos over in the Innovation Center, and I am getting information faster on Clean Air Pro than I'm getting it on Clean Air if I have both APs sitting in the same area. So a lot of this is now coming to fruition. Beyond and above that, AFC integration for 6 gigahertz. We're only detecting classifiers in 2.4 and 5 gigahertz, not 6 gigahertz yet. It's usually where the question, why, what's in 6 gigahertz comes, and I get to answer, what indeed. So we don't know yet. But I've got spectrum, and I've got the ability to record it. So where are we at? Clean Air Pro, Clean Air, detect and classify non-Wi-Fi interference. We've got that severity metric per interferer so that we can identify what's important. We've got establish air quality for all interfaces on the AP. And then the last one there, merge same type interferers. This is something that Clean Air has been able to do that nobody else has been able to do, and it's important. For instance, let's say I've got a Bluetooth device, frequency hopper, very wide in the room. Every AP in the room in that frequency is going to hear it, and I'm going to get an alert for that Bluetooth device from every single AP. What I have to do is merge that. I have to be able to look at that signal and find enough characteristics in that to say confidently at each AP, this is the same device. And then I build a cluster with that. So we're going to get into that just a little bit. But Clean Air Pro right here, both of them agree, channel 157, not a good thing to have right now. They all agree on the severity of it. Based on the RSSI, you're going to see different severities. So it's neck and neck for Clean Air Pro. There it goes. The thing that's important in here is that classification. And if you take a look up here, my severity is only a 5. I've still got 100% duty cycle, but at minus 93 RSSI, I could care less. That's not very severe to me. That's a 5. And if I look down here on Clean Air Pro, it's much closer to it. I've got a higher severity, and that's exactly what I should be seeing. So Clean Air Pro, metric-wise are very similar. They will not merge together because they're two different algorithms and two different radios, and I think that's probably best for the time being. How do we do that, though? What Cisco's done with Clean Air and what we did at Cognio was develop the ability to rotate and filter and isolate that frequency, the one that we're interested in that's non-Wi-Fi, from everything else that's Wi-Fi. And I presume everybody in this room has looked at spectrum in the Wi-Fi bands, yes? In a busy place, it's an ugly, ugly thing. So being able to tease this kind of detail out of the spectrum gives us the ability to isolate it and then do the measurements that we need to do the things like generate a classification that's reliable, provide the information we need to merge all these things together and reduce the number of alerts you're getting. The end goal of this is to give you actionable information, not just say something's interfering with the network. This is interfering with the network. And if you unplug that, it will stop interfering with the network. That's a really fun part when you have a problem that your boss says, what is it? And you say, it's interference. Because you know he's going to ask what, where, how. That's what you can get with that. So what do we got at the end? Up to 64 total interferers per AP, various conditions, add, merge, drop interferers from the tracking list. Merging. Got to have that merge. You have to be able to detect the on time and the off time accurately and track it. One of the things about detection that's always been true and continues to be true, if you've got a very slow wideband device, that's going to limit the number of dwells that I see it on. So I'm going to need more of that information to get it. If you throw on a very narrow band, solid device, for instance, like a video camera that does a continuous signal, I look at that every time I do a dwell and I get that classification much faster. So a little bit of delay in some of the wider ones or the less frequent ones, that's expected. Everything I tested so far, and I probably have the best set of interferers left in the world, you can't even replace some of them. I'm old. Some of the things that I've tested came up as not quite the same, but everything did classify that I tested so far. So let's talk a little bit more about merging. Since Clean Air's inception, there's been this constance of merging, right? That was very much required when we moved from the card that was in the laptop to an every AP item. You immediately have to start thinking about these things. Merging is represented in the controller, if you take a look at the Clean Air statistics, as the cluster ID. That cluster ID tells me that I've already identified that device as being the same. These same cluster IDs are all seeing that same device. So that gives us a couple of things. If I take that cluster ID down to the command line right now and I run that in the command line, it tells me all of the APs that are involved in that cluster, when I first saw that interference, when's the last time I saw that interference, who's closest to that interference, and that becomes my cluster center and likely where my AP is closest to that interference. The other thing this gives me is I've got RSSI metrics from every one of those. I know it's the same device. I have a solution set for location. That's what the other guys can't do, because if you watch those devices, they can't classify and say it is the same device. And if you can't say it's the same device, you might be trying to calculate location on 3 different devices. And that is going to provide you some challenge. So this is Clean Air in every sense of the way.
Sorry, Jim,
yes.
Question about that. If you were in an environment that had many Bluetooth devices,
yes,
you could identify individual Bluetooth devices? Yes. So you'd have a count of how many there were in the room of...
Yes, and that's important too.
And it's getting that from the spectrum that it can identify?
Yes.
Okay.
It's doing that from the spectrum analysis that we're doing. Clean Air Pro actually had the advantage of also being able to demodulate the MAC. So what I've seen so far of this, it's doing a pretty good job. We haven't taken it up and tested it with maximum devices yet, but in the first releases, they're getting it there. The other thing that I've got on this, well, okay, so detection time we talked about. One of the things that we get real importantly, I check every time because I came from Cognio, was if I turn something on, how fast do I detect it over here? And if I turn it off, how fast does it go away? Because that's really important to troubleshooting. When I turned it on in the room, I kept getting my Clean Air Pro AP kept coming up almost instantly. I couldn't put a timer on it. And that was closer to me than the Clean Air AP. But the Clean Air Pro was outperforming the Clean Air APs as far as detection time. Detection time dropping, averaged between 30 and 42 seconds, which is exactly where I wanted it to be for Clean Air. So it is very accurate. ML-based. I said that was in the name. I said we're using it. Not surprisingly, since we've been in this for 12 years, we have literally hundreds of thousands of signature samples on file that we've used to train our classifiers and build the classifiers. In the Clean Air days, all of it was code. It was like building, if you remember the initial launch codes, and rearranging all the driver load sequences so that you get a DOS machine to load. It's kind of how Clean Air went up. It was all very hard coded. You could not. Everybody got the concept that this was like a virus file that you could just update. You could not do that with Clean Air. It was very, very tight machine level code. This, on the other hand, is trainable. And we did train the classifiers that we're using right now using machine learning. It's static, it's offline, it doesn't require a tether to the net. But we do have the diagnostic functions built in to pull the data that we're going to run against that machine learning and that catalog of interferences we have. The goal of this ultimately is to answer the one question I got, everybody wanted. I've got this interferer in my environment only. Why can't I make that an interferer that reacts in the system? That's what we want to be able to do, is let you identify spectrum that is decidedly not Wi-Fi, and that benefits manufacturing and a lot of other industries that have these ISM devices that only they have. Prior to that, it required us to do a whole release, and that was cost prohibitive and labor prohibitive because this is going to solve one guy's problem, right? So this is something I'm very much looking forward to adding in. Right now, as I mentioned, if you want to take a look at the 6 gigahertz spectrum, you've got the 5 gigahertz spectrum in ICAP. You've also got it in 6 gigahertz. And the reason I like having the spectrum in 6 gigahertz is because what indeed is in my way in 6 gigahertz. And for me, looking at spectrum, that's not an opinion. That's the fact. So if you see it, it's there. It's interfering with something. AI enhanced RM update. How many of you heard me talk last time we did Tech Field Day about AI enhanced RM? This continues to get better. For those of you that didn't hear about that, what we've done is we've moved the group leader to the cloud, and we have a new set of algorithms that is now running what we call AI enhanced RM. Now, the primary difference of this is this gives me a lot more data to work with. On a controller today, I get the last 10 minutes of scan data that I'm using for every decision. If I decide that I'm going to anchor the controller at midnight and run it once a day, the last 10 minutes of data at midnight is what I'm going to make my channelization and power decisions on. That may not be optimal for your lunchtime rush. So 14 days of data is stored in the cloud. The cloud actually becomes, the AI analytics cloud becomes the RF group leader making all of the RM decisions for the controller. To the controller, this simply looks like another RF profile, another group leader that it's associating to, because that logic and functionality has been resident in RM since the day it was born. So from a failover standpoint, if I lose the cloud, it rolls right back to the controller. The group leader's running the same configurations. RM is not exactly a critical algorithm. It can drive your network very unusable if you let it go. But this fails over, you wouldn't even be aware that it fell off the cloud or went back onto the cloud if you had a disruption. Some of the advantages this gives me, actionable insights. Some of the data that I'm able to pull now and analyze from the telemetry that's streaming, constant data that's streaming, is the ability to determine when you have busy hours. The advantage to that automatically becomes I can optimize a configuration at noon, I can implement it at midnight. We give you the rules and tools to handle that. We're also taking a look at the config decisions that you've made. If the config decisions don't seem to match the telemetry we're seeing, we can make recommendations on that. In the insights, anything you click on will take you to why we think that, what we think the outcome will be if you make the change. Here's how to make the change. Do you want to schedule it now or save it for later? So everything is left up to the administrator. What do we think? We think that's going to provide a real increase in operational efficiency. The beauty of it is in the displays, because I can get every bit of data out of this dashboard just by clicking on things that I used to take an hour to parse a file out and dig out of it. What you need to get started is AI Enhanced RM in the cloud. That's the AI Analytics Cloud with a on-prem Cisco DNA Center managing a C9800 controller. DNA Center provides the telemetry path to the AI cloud. It also provides the control path back down to the controller to issue the instructions to the APs.
I wanted to talk about something as part of AIOps. That's something that we always do. And that's one thing, that's firmware upgrades. Raise of hands, how many of you have done a firmware upgrade on devices? I'm guessing all of you.
Upgrades all the time.
All of you. I think I have done it too, right? I think generally how it has gone is, you go in, you do the firmware upgrades one by one, it comes online, and, then you wait for people to come in. When Meraki started cloud management, I think what we did first was we automated the way firmware is rolled out. But I think what I want to talk about today is what happens after the fact and how we use that data into our firmware rollout process. So if you really think about it, like if firmware rolls out, you schedule the rollout, and now people come in, let's assume you have an issue. That happens. I think if anybody says we don't have issues, that's a lie. But if you have an issue, the first thing that we do is roll that firmware back. And then, you try to get the network back to normal. And then you try to work with customers, or either you open a support case and you try to provide that information. But I think one of the biggest thing that is missed is we don't capture what exactly happened, and it's after the fact, because the first reaction is try to roll it back and get to a stable state where we understand what's happening, right? And that's where the real journey starts. So over here in firmware upgrades, this is how you schedule it. You set up the upgrade time and window, if you want to try and beta upgrade or not. But now let's say you're trying to roll it back, right? So you go into dashboard, you go through this process, and I'm going to go to the end of the process, because at the end, there is something that's captured that helps us tremendously. It tells you why you're rolling back. And depending on what you select, right, you have to provide some feedback. What's happening is we are capturing this data for every device that is being rolled out. We are capturing this data. And what happens is there are two things that we keep track of. As we are rolling out the firmware for our customers, we are looking at how the APs are behaving in the field, and if there are certain metrics that are performing well. If APs start to panic, we obviously know. Proactively, we are notified to understand how the APs are behaving, and that's one way we kind of get involved and we take action. And I'll talk about the action a little bit. But the other thing that we talk about is the analysis of the feedback that we are receiving. Based on the feedback that we receive, we have NLP analysis running in the background. We have people that are looking at common trends and themes that are coming into picture. And based on that, we kind of start looking at if there are common trends coming through from the field, from our customers. Because that's one thing, right? Like as you start rolling out firmware, there are different environments that the firmware gets rolled out into. And there are edge cases, there are cases that you run into. And we want all of that data. Somebody asks me, Sanmil, what do you do with the data that all of the Meraki dashboard sees? We have millions of APs online. When we roll this out, we are trying to look at that data and we are trying to identify what actions we can take. Now, based on both of these information that we get, we can actually start looking into, proactive analysis. Like if we want more information from a customer, we have reached out to customers. We reach out to customers and we ask them, hey, you know what, customer A, what did you see? What was the behavior that was observed? A lot of times customers don't even report cases because, they've now just rolled back. They're like, I'm good. Whatever happened, I'm going back to my old state. I'm going to, not worry about it. But we have to think about this. So this is a firmware release cycle that we do. So initially when we release beta firmware, we kind of start, rolling out. Customers do get scheduled for automatic upgrades based on your window. They can cancel that. But if you go through, we are constantly keeping track of how the APs are behaving in the field. And depending on the rollback, if they do it, we are starting to look at the analysis. There's a lot of issues. There's a few issues that we've actually caught because of this behavior. And then as we move towards our GA cycle, right, we keep on hitting those metrics, adoption metrics, and when it goes GA, even during the GA cycle, say we have a security patch that we release, or for whatever reason, if that introduces any issues, there's another rollback analysis. And because for our larger customers, there are some customers who just use GA, some customers use beta code as well. But throughout this entire process, we are taking that feedback as it's continuously being monitored. This is happening globally today. For all of our customers, there's millions of APs that are online and devices too, but it's happening globally. Now,
Is this only specific to APs and access points?
other
Or is it
products,
the switches?
other products also do it. It's at different stages, but in some way, shape, or form, there are products that are looking at it. Now, the question that I get is, how effective is this, right? What have you achieved with this? And we've been doing this over the last 7 years. Obviously, the process has evolved and will continue to evolve, right? But over the last years or so, in 2020, that's when our MR20X, MR27 firmware went live. Because of this rollback analysis, we were able to catch 3 issues, and we were able to proactively reach out to customers, identify those issues, catch those fixes, and roll this out in subsequent releases. We didn't have to wait for somebody to report that issue. We actually proactively reached out. And then there was another set of issues that we caught that impacted 12 customers. The reason I say that is because that's also important. If there is a wider impact that we see, we have instituted processes where we've reached out to customers and notified them proactively. Hey, you know what? You may not know this, but you are having this issue. Our support teams are then engaged, and we are done this. If in case it happens during a holiday season, because that's very key, right? Like Black Friday or 4th of July. If it happens during holiday season, we can work with our customers to ensure that they are aware and work with them. We have processes that kick in place. So this is an extremely evolved process, I would say, over time. It's really dear to my heart because I've been through some of these issues, identifying issues. It's like every network engineer deals with this on a day-to-day basis. So I hold it very near and dear to my heart. And I wanted to talk about this. It's something that, the team spends a lot of time on. And it's nothing that you see in dashboard. Like I show you the interaction. The reason I started with dashboard is it's like 4 or 5 clicks that you do. But all of this happens under the hood. There's nothing that you see in dashboard, but this is what the teams are up to at Meraki. You're truly getting a view of what happens in the background.
So I do have a question about the issue right there on that slide. Do you think it'd be beneficial to expose some of that data in the dashboard to customers? Like, hey, we've noticed this kind of issue level on this firmware in the beta releases.
So we have changelog notes. So when we notice that issue, we do capture it in the changelog notes, and you see it after the fact. Obviously, there is a lot of assurance-related aspects that we're doing, surfacing information to help our customers, understand what is happening in their network. Again, it's a constantly evolving process. If there is something that we have to notify our customers, hey, you know what, something has happened. What we've generally done is we've reached out to customers and let them notify them, because just putting a blanket banner can also mean like 10 people can open support cases at the same time, and that can also go down different ways. So we really have to think about how customers operate, but if we see that something is definitely causing a problem, we do reach out to customers.